And I'm happy to introduce you to Alex Gryson from Sculpteo. And his topic today is how software is holding back the 3D printing service bureau.
Well, hello. So as I was just introduced, my name is Alexander Gryson. I'm a product owner for Fabpilot at Sculpteo. I don't know if you know Sculpteo. I'll just go through a little bit of what we are. So Sculpteo, as you may know, is a service bureau. We're mainly known for that. We were founded in 2009, but we're also a few other things. We also have a design studio. So if you have design requirements, you want to design something for additive manufacturing, we can help you out with that. And also, what I'll mainly be talking about is our software. So if you have machines, if you know someone who has machines, we can help you out with that. And we're just going to tell you a little bit of a story about where we're coming from, the challenges we've faced, and kind of how we solved those using our own software. So Sculpteo, as I've explained, it's always been cloud-based. We run online. We print today about 2,000 parts a month. We were founded back in 2009. The team who started that have always been software engineers. Our CEO himself is a software engineer. That's his background. And so we have always tried to tackle our problems using our own software and tried to develop our own software to solve those problems. We started out very small, as most people would have, back in 2009. And as we grew and as we changed, we encountered a lot of difficulties and we needed to solve those problems. So one of the problems we have, especially for any service bureau, is it's a very heterogeneous environment. You have lots of technologies, you have lots of materials, you have lots of types of files coming in, and you have to be able to handle all of that. And you have to be able to handle it just as efficiently for one technology or another technology. As well as that, we're based in multiple locations. So we're headquartered in Paris, but we also have a manufacturing facility over in San Leandro. And this was really a very big change for us. And if any of you are service bureaus or are thinking getting into that kind of expansion, you're going to see a big difference when you go into multiple production sites. Because one of the difficulties you have is, say, for example, a nesting. Okay, you're producing on an EOS. You have a nesting. If you have a problem with that nesting, trying to communicate with your expert back in Paris, you're uploading gigabytes of data, downloading gigabytes of data, getting them all back again just to have an answer to a fairly simple question, potentially. So this really puts a lot of stress on your organization and how you work. But there's a lot of advantages of doing that. Sculpteo, we produce parts for production in large and small quantities. The average order is about 10 parts, but that means there's a lot of a long tail. There's a lot of people who order 1 or 2 parts, and then there's people like AudioQuest up here who order tens of thousands of parts every order. Okay, so this is really talking about production here. This is end-use part. They cannot produce it in any other way, and we are the person who produces for them. And you get other kind of smaller runs, smaller production runs around here, and other kind of more kind of bespoke projects as well. So there's a wide range of projects that you have to deal with, and we'll be talking about some of the difficulties when you get into that, especially when you have people that are not necessarily engineers, but they've been able to design files, they've been able to provide you with those files, and they need you to produce them on time, even though it's maybe not the best file to work with. Because really what we're talking about is we're manufacturing, but with prototyping machines. And this comes with several advantages. I mean, everyone here has probably spent the past 24 hours telling you those. I mean, we see that we have the geometric freedom. We see that it's fairly agile. We can see that we do very small production runs very, very easily, very, very efficiently. But there are other issues, such as managing humans, managing all these heterogeneous machines, trying to get those procedures in place, safety, things like this. So it's quite a difficult thing to do, because the machines, in many respects, aren't really designed for that kind of throughput. And that's what you have to work with. And this touches on what I was talking about earlier, was very often with many of our customers, their first idea of what specifications are for a product is they figure that the 3D will be enough, right? That's all you need, right? It's 3D printing. And it's certainly not the case. You know, there's all kinds of things about the solidity of the file. Is the 3D even good enough to print? You got all these kinds of issues that you have to tackle, which your customer or end user may not even be aware of. And this is not to belittle people who are kind of ordering. This is also with engineers. You could have a very experienced mechanical engineer who's been using other techniques their whole career, and now suddenly the boss is saying, we've got additive manufacturing here. I'd like you to investigate how to use it better. Okay? And the difficulty there is, well, how do I do that? What do I need to tell you so that you know how to produce it? What do I need to get back from you so I know how to design it, etc.? So this conversation is very, very important, not just as a service bureau, but even if you have an internal lab and you're trying to expand the knowledge of your teams, even your experienced mechanical engineers. Because as you can see, there's a lot of steps necessary to produce good parts. Everything from the upload of the file, what kind of file do you need, what kind of file are you going to work with. The machines generally use meshes, but you're generally going to be designing in CAD. Then you have to go through the actual preparation and production of the parts, all the way down to QC. So there's lots of moving parts, and there's lots of things you need to do to produce good parts, and there's just as many opportunities for things to go wrong. I saw there was a talk here, someone about mass customization. And I mean, Sculpteo, we've done a bit of that, and it's wonderful until you have 400 iPhones on the table, and each of them are for a different customer, and all of them look the same, and all of them have one tiny little difference. And how do you manage that with enough speed in an industrial context and prevent errors and sending the wrong file to the wrong person? These are very complicated problems which you typically don't have in other industrial contexts, but you do start to have when you're talking about mass customization technologies such as 3D printing. And that's just one example. When I'm talking about traceability, you've also got the file repair, you've got security of files. One of the things, I mean, we're cloud-based, so I'm sure that question is going to come up later, but one of the things which I'm often surprised at is, oh, cloud, we're a bit worried about security on the cloud. And then I say, well, how do you put files on your printer today? And the number one answer is USB keys. And where I used to work before, you couldn't go on site with a USB key or you'd be fired fairly quickly. Okay, so it's kind of ironic, I find, that the cloud gets this bad rap for security, but in many respects, you can improve security by having one single file, one source of access, and you're controlling that access, and you're able to log access to those files. There's a lot of things you get for free when you use that kind of online structure, and we'll be looking at that a bit later as well. So I think I've spoken enough about the problems and the difficulties and the growing pains that we've had at Sculpteo as we've gone on. As I said, we need to look at ways to try to solve these issues. And everything you're going to see, we tried out at some point. I mean, there's the simplest thing to do is probably like a Kanban board. You can set it up with Post-its. And there's a lot of small service bureaus. This is the first thing they do. I don't know if any of you guys do it, but you definitely know someone who does. Because when you're starting off, when you're in a small lab, you've got 2 or 3 machines. This is easy to set up. It's cheap. It's easy to understand. There's no training required. But the problem is it doesn't really scale. You're not going to be able to do a lot with this when you start dealing with larger quantities or when you start trying to deal with, as I said, 400 iPhone cases. That's hard to specify in a Post-it, right? So, it's great, it's easy, it's where you start, but it's not where you're going to stop. And you're not going to be able to grow very quickly with a system like that. So typically, you'll go now to the other extreme, a traditional ERP. And these, again, also have enormous advantages. As we can see, all of the problems we have with Post-its disappear. You got incredible traceability down to each and every single part. You can scale to millions of items, if you like. But you're going to lose a lot of those advantages you had with Post-its. It's very difficult to set up. It can take months to implement properly. And also, it puts a lot of a brake if you want to change your process in the future, because you're going to hesitate on the cost of re-implementing this and trying to change all of this and reintegrate this system. So, there is a lot of value, and there is a certain scale at which you will need to seriously consider this kind of thing. But there's not really generally enough value for an additive manufacturing environment, especially for a service bureau, to be able to seriously consider this in the long term. And so you need to find something in the middle. Now, excuse me for the marketing talk here, the digital chain, and it's the key, and all this kind of thing. But the idea is pretty simple. It's that basically the Post-it boards, the advantages that you're dealing with here, you want to have that kind of simplicity, and you want to have any information that you're gaining as you learn feeding into how you do your process. You want your process to be able to adapt as quickly as the whiteboard with the Post-its. But you still want to have that traceability and that scalability that you're going to be able to find with more traditional ERP systems. So I'll skip past the diagram and start looking at some concrete examples. What you're looking at here is an approach that we've taken at Sculpteo. This is a project workflow, which I'll be able to show you later. Our stand is just there, so I'll be able to demo it to any of you who are interested. So the project workflow here, what's interesting about this is that I know who is accessing my files. I can upload these files. I can upload in about 35 different formats, including native CAD. That then is then converted into a native Sculpteo format, so we can apply all kinds of operations to it, which we'll be looking at later, repairs, analysis, and things like this. You have a conversational flow. This is one of the things I didn't mention about when you're dealing with an ERP. When you have your mechanical engineer who's designing the part, he'll be using, I don't know, maybe using Autodesk or SolidWorks or whatever. But then the guy in production is using another piece of software, okay? You know, Magix, NetFab, and things like this. And the problem is that if there are issues and they need to communicate those issues, very often there's going to be communication problems. And one of the advantages of this conversational flow and using a common tool between the two teams is that communication is much faster, much more efficient, and you're actually looking at the same information. As you go across, you see the files, you see the production list, and you can generate your price estimates. And whenever production touches your file, you know when they did it, who did it, and they're added to your team here, so you'll be able to track all that throughout the life of your project and reorder parts as you require. But it's not just there. There's also collaborative design tools. This is what I was talking about, having the same vision of the product. This is not very complicated. It's not very complicated tools, but they're enough to really save you in a pinch in production. Very often the problems are things like orientation, solidity, and things like this. So you need to be able to review those with the person, speak the same language, be looking at the same tools, and know how to fix the issue with the person. We can do things by the fact that we're using the web, gives us a couple of cool little toys to play with, such as real-time shared 3D viewers. I can move the 3D, it'll move on your screen on the other side of the planet. So you can really share this across multiple browser sessions, and you can work together much more efficiently. I touched on our review tools. So these are the first tools that we developed at Sculpteo. Because as a service bureau, we deal with members of the public, you need to communicate in a very simple way what the issues are with their product. It needs to be one click, not 20. Okay, so for a very simple analysis of a file like this, if it's going to be solid or not, you allow the production staff to set up what that material is like, what that machine is like. And that's going to inform then the solidity. You're going to have cutaway views. You're going to be able to, check out the exposure profile here as it's going to build to see if there's going to be delamination or crashes and things like this, as well as do basic measurements for kind of verifying tolerances at the end of the production. And as well as review, I spoke very quickly about this. We also have optimization. So we're not very big into doing CAD or doing actual design. That we believe that there are better software packages for that. However, there are some simple things that you can do after the fact that can really make production much easier. If you're dealing with metals, if you're dealing with with HP, for example, you're going to be able to generate lattices. That's going to save some of your costs. You're looking at hollowing here. That's with more SLS kind of powder-based technologies. You'll be able to add some holes to recover powder if you want. So these tools are built, and again, they're adaptive. As I said, we convert into our own format, and then we add these operations on top, which means that if I change the scale, it's going to update the lattice automatically. If I change the material, it's going to change the parameters of the wall thickness to adapt to that. So even if you uploaded a mesh, we're now able to, in a very reactive way, adapt to how you're changing your file here. The work in progress here is, for the moment, it's just cubic lattices, but we've built it in a way that we'll be able to support custom lattices in the future. And again, we get into production. This is our Post-its. And this is our version of a Post-it. It's a little bit more detailed. You have the ability to filter throughout your jobs. You see the status of the job, what the items are. And you can see basically what's going on at any point. Something I didn't really talk about was the automatic routing. Based on how you've set up your machines, our system will automatically route to the available printers. You can manage that yourself. But if, for example, you're printing, I don't know if I have an example here, but okay, I don't. But if you're printing 50 items and 3 of them fail due to some issue in the print, you can simply say that, and the system will automatically route them back in. And if you try to do that with Post-its, you're not going to have a very good time. And that's the reality of production. Errors happen, problems happen, and you need a flexible system to be able to reproduce those items in a very quick way and also communicate that information back up to the project that we saw earlier so that the end user is able to see what's going on. Another thing, and this is kind of the killer feature, right? If we were an Xbox, this is Halo. So this is our automated nesting. Okay, this is the final function which we developed, which allowed us to turn off all external software. As I said, we produce 2,000 parts a day, and we do it exclusively on Fabpilot technologies. And this is, I nested 350 parts in 2 minutes and 40 seconds, and I can repeat that with you. And that was lots of different parts. It's not just cubes. And in fact, that's one of the important things, is that you'll see this curve here. We're doing some pretty cool things in software to solve hardware problems. When you're printing in a powder bed, right, you've got your EOS machine. Sometimes if you have large variations, you see these large spikes here. If you have those large spikes going on, you're going to have a lot of curling issues. And we've reduced them internally by 30% simply by moving some items up and down in Z. And our nesting algorithm will do that for you. And you can have that go slower and be a bit more accurate, or turn it off altogether if you just want to have fast nesting. And again, because it's cloud-based, one of the big advantages here is if you're in an environment that has powders floating around and things like this, you don't want a computer that has a fan powering a graphics card, sucking in all that powder and setting on fire. So you're generally going to have thinner, lighter clients, touchscreens and things like this. And you need to be able to, potentially work with the 3D there. And the only way to do that effectively, we found, is using this cloud base. Because your thin client, your front-end client, is not doing that much heavy lifting. The cloud is doing all of that. You're able to do this on very thin clients in the production front end. And one of the things I didn't mention about this nesting here is, as I said, one of the other advantages of the cloud, I mentioned it earlier, was the idea that our teams in San Francisco and our teams in Paris can communicate using a single link instead of gigabytes of data. I can load this, you'll see it in 15 seconds, is a full nesting of 350 parts instead of minutes to download gigabytes of data. And just a few more. So we mentioned this, the operations manager. This again is our Postit approach. So you got this very simple way to use touchscreens as well with your system, and it's all integrated. If you put anything into error, it's going to pop along back into the backlog, and you're able to take care of all of this fairly easily. So as I said, better than Post-its. I've mentioned that it's a cloud-based solution. So this thin client provides a lot of advantages. And also it's a product, and you can get this yourself. It's fairly reasonably licensed. As I said, I can give you a demo at any point. I've got my dream team over here if you want to give a wave. And so basically what you will be getting is about 10 years of experience in development of a relatively big service bureau and all of the tools that we use internally for your own production center. And it's easy to set up and training that's included in the license price. You get to talk to me a bit more, and I can help you out with that. And all that's left to say is thank you very much. You can contact me here or now if there's any questions.